Have you ever wondered why time moves in only one direction? Time is one of the most mysterious variables in science, and its nature has puzzled philosophers and researchers for centuries. At least once in your life, you must have questioned what the direction of time is. It is easy to say that time moves in the forward direction. But what is this forward direction? Is moving backward in time even possible? If yes, then why don't we experience it? Time travel means you can move between different points in time, and it sounds like a very cool idea. For a moment, let's just forget the world around us and dive into the quantum world. Here, things are governed by a different set of rules or equations that make time reversal a reasonable possibility. So how do we do that? It's simple. Just take any equation that contains time t, and replace it with minus t. If the resultant expression remains the same, then the phenomenon won't change if you reverse time. Out of all the four fundamental forces in nature, three are known to follow this beautiful time symmetry at the quantum scale. But when we come back to the macroscopic world, the possibility of time being homogeneous fades away. On a large scale we can only experience time that points in one direction, the forward direction we like to call. Over the years, scientists have tried to connect the direction of time with the universe. In 1927, English astrophysicist Arthur Eddington came up with the arrow of time that explains the direction in which time moves. The most significant arrow of time is what we call the thermodynamic arrow of time. It says that time always moves in the direction in which the disorder of the universe increases. Consider an egg that falls on the floor and breaks. The disorder or the entropy of that system has increased. But the reverse is not possible. A falling broken egg cannot become whole. If you don't like eggs, then imagine a deck of cards that is perfectly ordered. If you shuffle it, it will become disordered. You cannot get back the original order by reshuffling it. So if you consider the universe as an isolated system, then the arrow of time points toward an increase in entropy or disorder of the universe. Although the thermodynamic arrow is the most significant one, it's closely related to another time arrow, the cosmological arrow of time. The Big Bang theory says that our universe came into being about 14 billion years ago from a singularity. Ever since, it has been expanding. The cosmological time arrow points in the direction of the expanding universe. Without expansion, there would be no change in entropy as per the thermodynamic arrow of time. The two arrows discussed so far are something that you cannot comprehend in day-to-day life. But there's another arrow that you can very well understand. Can you feel full without even eating something? The answer is no, because to observe an effect, you need a cause. So to some extent, by causing something to happen, we are controlling our future. But no matter how hard we try, we cannot change the past. Although this is not related to physics, causality is intimately linked with the arrow of time. If you look deep into nature, there is one pattern that you will observe. All kinds of waves, be it light waves, radio waves, sound waves, or even water waves, are always radiative. They always seem to expand outward from their point of origin. This asymmetry can be related to another time arrow called the radiative arrow. That's again linked with the thermodynamic arrow, because as the radiation goes away from its source, the entropy increases. So far, you must have understood that if you reverse the direction of time, the universe won't remain the same. But what if I tell you that there is a way by which you can reverse the direction of time, and make the resultant universe identical to the current one? Well, this is known as the CPT symmetry. C, P, and T are operators in physics. C means charge conjugation, replacing all the particles in the universe with their corresponding antiparticles. P means parity inversion, taking a mirror image of the universe. Finally, T represents time reversal. So if you take a mirror image of the universe, replace its particles with antimatter particles, and then reverse the direction of time, the resultant universe will be identical to ours. The CPT symmetry is the highest form of symmetry obeyed at all the fundamental levels of nature. The concept of the time arrow is still one of the most mysterious problems in physics. Although most of the physical processes at the microscopic level are believed to be either entirely or mostly time symmetric, yet, at the macroscopic level, it often appears that this is not the case. Thus, There is an obvious direction of time, and the arrows discussed in this video are adept at explaining its direction. Do share this video, and in the comments section, let us know what you think about the direction of time.